We've looked at symmetry, lines of symmetry, and now we're going to look at something slightly different, which is rotational symmetry. So rotational symmetry occurs when a shape can be rotated and it still looks the same. And the order of rotational symmetry of a shape is the number of times it can be rotated around in a full circle and still looks the same. It's a bit of a mouthful of a definition, but I'll illustrate. So for instance, here you have a star shape. And if this is the point of rotation, you can see, keep an eye on that. If we were to rotate this figure in that direction, so that becomes there, that comes there, you can see that this shape, these shapes are identical. Then this little blob, if we were to rotate the whole shape, so it's in that position, you can see it's still the same, etc. And then it goes around to this position, and it's the same, and it goes around, and it ends off where it started. So this has an order rotation of 5, because we moved it 5 times around in a circle. Let's take something like this. So keep an eye on this point here. That's our reference point. If we were to turn the triangle in this direction, you can see that this and this does not map together. This is the original position, this is the current position. And then if we turn that around again to this position, again, it's not in, it doesn't look like the original. And then similarly, if we try this one more time and it gets to there, it still doesn't look like the original. So when it gets to there, it does look like the original, so it's gone back. And so this has a value, a rotational value of 1. And this has a rotational order of 5. So if we put these two things together, the lines of symmetry and also rotation order, and then we look at the properties of the quadrilaterals. So this is going back to look at the quadrilaterals, which we started to look at earlier. And if you remember, there were 6 special quadrilaterals, and they all have different symmetrical properties. So let's look at this. This is the square, and the square is defined by having the same lengths. Each of these 4 lengths are the same. And so there are 4 lines of symmetry, as we saw earlier when we were looking at this. So it can be folded that way, that way, that way, and that way. And if you were to look at any of those corners and then rotate it to here, it would look exactly the same, and then rotate it to here, and then back again. So there are 4 lines of symmetry and rotational order of 4. Let's look at a rectangle, and a rectangle has 2 lines of symmetry. So it can be folded. If you remember, a rectangle, that the lengths are in pairs, so that and that are the same. This and this are the same. So as far as symmetry is concerned, if you fold it down there, this side is identical with that side. If you fold it there, that side and that side are the same. But there's no other way that you can fold it. So, and it looks the same. So there are 2 lines of symmetry. And also there's only 2 positions where this, if you start rotating it from around here and you go around, does it look the same? You can try this yourself with a sheet of paper. So 2 lines of symmetry, rotational order of 2. We look at a parallelogram, and if you remember the parallelogram, the 2 sides here and these 2 sides here, so they're the same, and it runs in like a parallel track. And the lengths of these lines are not the same for a parallelogram. And there's no way that you can you can draw this, as you can draw lines of symmetry on them so they fold over exactly. So there are no lines of symmetry in a parallelogram, but you can rotate this. So if this went around here, etc., you will find two positions where they are the same. Now the rhombus looks very similar to the parallelogram, but the sides are the same. So these sides are the same with the parallelogram, they weren't. And so because the sides are the same, that changes its abilities, its properties. It has two lines of symmetry and it can be rotated twice around in a full circle where it looks identical. Next one is a trapezium. Trapezium has this sort of strange shape. Some of the trapezium structures are symmetrical. So, for instance, here, this is a trapezium and there is a line of symmetry that goes down the middle. So when it falls over there, they're the same. But the majority, like this one, they don't match up when you fold them over. So they would have 0 lines of symmetry. And then lastly, with the kite, there is one line of symmetry that runs down it, and one position where it looks exactly the same as it's rotated around. So you can try some of these things in your own leisure time and experiment. But essentially, just try to remember